Greetings of the day. I am Astro Jane Fernandez, and my teammates are Hitesh, Hanisha Shani Gonsalves, and Gautam. The title of the project is Rescue Device for Open Bowel Accidents, and the project ID is PROJ EAP 16. In India, for the past few years, there have been several accidents of children falling into abandoned bowels. These bowels seem to be the dead pits and thus start to take many innocent lives. In cases like these, the normal operation of child rescue is done by using big machines and large manpower. The rescue process is very long and complicated. Thus, as engineers, we have to come up with a solution, that is, a rescue device for open bowel accidents. Our approach was to make an adaptive design structure that meets the required constraints of any bowel parameters. The proposed device not only saves the child, but it's also easy to operate, reduces human effort, and saves the child in less duration of time. Cases of open bowel accidents are most prominent in the following states, where Haryana, Tamil Nadu, and Gujarat are right at the top. Our state Karnataka grabs an 8.8% of the total number of open bowel accidents. If you see the histogram from the year 2010, there hasn't been a decrease but a gradual increase in the open bowel accidents. Let's talk about the traditional rescue method by using a life scenario example. Prince, a 5-year-old boy from Haryana, unfortunately fell inside the bowel. Food, water, and oxygen was provided with the help of pipes. But what actually took place? A vertical hole was dug and then a horizontal hole. Obviously, we can observe it is a very long and time-consuming process. It took them 48 hours. It could also be risky because in some cases the sand is very loose and the walls of the borewell could collapse. Prince is lucky to be among the 30%. What about the others? Hence, we had to come up with a unique and effective solution.
The objectives of a proposed device is to make an adaptive design structure that meets the required constraints of any bowel parameters, to find the position of the child, to supply oxygen to the child and to also detect the level of oxygen present, to place the devices attached to a control panel at required level, to mobilize a suction mechanism that provides adequate support to the child, and finally, to establish a baby retrieving mechanism for rescuing the child safely.
Now, let us see the list of hardware and software components used in different sections of our project. Monitoring system. Here, we have used IR CCTV camera, video transmitter, video receiver, fiber optic cables, and a monitor. Oxygen level detectors. Here, Arduino Uno, gas sensor, which is MQ135, buzzer, and 16:2 LCD display, and an LED. Baby retrieving mechanism. Here we have used MG995 servo motors, which is used for the movement of links, end effector, which is the base, and SG95 servo motors, which is used for the movement of the base. Controller. Here we have used FlySky i6s transmitter and receiver. Suction mechanism. We have used pressure regulator, suction cup, and pipes.
Social relevance. The main application of this device is to be a rescue device for open bowel accidents. But due to its unique capability to mobilize and rotate inside any cylindrical or hollow object, it can also be used as a cleaning device. The end effector, that's the base, can be replaced by using a rotary brush. Hence, it can be used for cleaning applications of a pipe or chimney. It can also be used as an inspection device. We know that in manufacturing industries, the final product is required to go through an inspection process for quality control and to prevent any leakage that can be fatal. Thus, Special inspection instruments are added to the mechanism, like sensors, that can detect any kind of defect which may be the reason for serious accidents.
What you can see here is the block diagram of our mechanism. So we have a power source that is connected to all of the devices and the mechanisms. This is further divided into a control panel and the controlling system. Our control panel mainly has the baby retrieving mechanism, that is our primary support, the suction mechanism, that is our secondary support, also the oxygen pipes and the exhaust pipes that are used to supply oxygen and remove all the toxic gases and harmful gases present inside the bowel. We also have a monitoring system and oxygen level detection system, and also the FlySky I6S, which is used to control the baby retrieving mechanism.
Let us now understand the methodology of this rescue device considering a scenario where a report has been made of a child being trapped in a bowel. What do we do in this situation? We immediately reach the site, secure the scene, and isolate the area to prevent crowd gathering and unwanted objects falling into the bowel.
Next, our team analyzes the texture of the soil, gathers the information about the depth of the bowel, and also formulates a plan to send the control panel in, and this marks the beginning of our phase 1, that is the support phase.
Then, deploy the control panel that constitutes the IR camera with night vision, transmitter, baby retrieving mechanism, and also pipes that lead to various mechanisms like suction, oxygen supply, and vacuum tube.
The IR camera in the panel provides the orientation of the child and depth at which it is trapped.
Once this is done, we detect the level of oxygen and other gases present. Based on this, we supply required amount of oxygen.
Using the camera, we clear the debris and attach the suction cup, which is our secondary support that provides better grip and stability.
Mobilizing the baby driving mechanism, the vacuum tube attached to it eliminates the debris present around the baby and the mechanism provides the adequate support needed.
Our last and final step is to ensure that the entire plan is executed well and the baby is retrieved safely and then handed over to the medical support. So this marks the end of phase 2 and we have safely retrieved the baby out.
Monitoring system is initially used to find the position of the child and then monitors its position till the child is rescued. This system consists of IR camera with night vision, transmitter, receiver, and monitor. The visuals of the child obtained by the camera are transmitted by transmitter to receiver via optical fiber cable and can be seen in monitor.
We have researched many mechanisms used to retrieve the baby and incorporated all the key aspects and come up with a unique approach. Now we have a video demonstration. This is the end effector that opens up into a base when it's below the child. We have modified the links by converting them into different parts so that they can also be mobilized and we can adjust them as our requirement. Given this mechanism, we have made many changes and improvised it with respect to its degrees of motion, stability, and space occupancy. You can see our improvised mechanism in our demonstration video. Now let's see what are the different parts of the controller and the control panel. As you can see here, we have a FlySky i6S controller, the transmitter and the receiver are shown here. The control panel has mainly the camera, the suction and the baby retrieving mechanism attached to it. So the control panel is the mobile part that will be moving inside the bowel and rescuing the baby out. So this can be extended to the length of the bowel by using a thread or a strong gauge wire.
This mechanism provides adequate support to the child. A suction cup is sealed against the head of the child and the air is squeezed out of the cup to create a low pressure inside the cup that creates the suction.
Inside the borewell, to detect the concentration level of oxygen, we use an oxygen detector which has an MQ135 sensor. We observe the level of oxygen is low, so the buzzer rings and an alert message is displayed on the LCD. Hence, we supply oxygen through a pipe and the oxygen concentration level is maintained. We now observe the buzzer stops ringing and oxygen level is normal. Harmful toxic gases are removed by using an exhaust. So now, as you can see, the oxygen level is normal, and when the oxygen concentration decreases, buzzer starts ringing and alert message is displayed.
Start. Hope we have painted a clear picture about the proposed rescue device. This device will rescue the child from the bowel, thus targeting to save a life with least amount of injuries possible. With a number of different approaches present, how is our device unique and better? Let's see.
As we have integrated support and rescue mechanism, it decreases complexity, thus avoids confusion and is easy to operate. As most of our operation is automated, it requires less human effort compared to traditional approach. Finally, based on the points mentioned, we can assure that a mechanism is safe and consumes less time.
Human life is precious. The proposed device is a significant attempt to save lives of children with a success rate of 80%. Its unique capability of mobilizing and rotating opens a wide scope of applications in manufacturing industries and other relevant fields. The proposed device can be elevated in the future to further research and development. It can be automated and completely responsive to various scenarios by using artificial intelligence. The proposed device is an approach of an adaptive design that meets any bowel constraints, thus matching with the industry standards. It can be commercialized as a product which provides an essential service. Economic value is definitely added through social responsibility and relevance. The targeted users, the government, to provide the device for rescue operations and various manufacturing industries. It can be used for inspection and cleaning. Thank you.